Hello friends, welcome you all in T.Y.B.Sc Electronic Science class. In this lecture, we shall discuss the Advanced Digital System Design paper first, and the topic of discussion is Implication Chart Method of State Reduction. Myself, Patil, Department of Electronic Science, KTHM College, Nasik. So let us start. First, we shall discuss the implication chart, how the implication chart is constructed and how it is used for state reduction of sequential state machine. Here in this picture, the unfilled implication chart is shown. The example taken of sequential state machine containing 5 states from S0 to S5, and the 5 states are to be arranged in the form of grid like this. First, implication chart. The implication chart is a graphical method to identify redundant states. In earlier lecture, we have discussed the equivalence class method of finding the redundant state. In the equivalence class method, what we do, we partition the number of states according to their output and the next states, and we make the group of those state, and we further go on partitioning the states till it is possible. Once it is completed, the states which are coming under the same group are said to be equivalent and is redundant, so we can eliminate the number of state using the equivalence class method. But that method is somewhat critical and takes much time to find the equivalent states. So the second method is here, implication chart method. In this method, we use the grid array as shown in the picture. It uses the grid array to list the possible state equivalencies for different inputs. The chart is constructed by all the states except first, in this case it is S0, along the vertical axis, and all of the state except the last, here S5 is the last state, along the horizontal axis. The intersection of horizontal and vertical state spaces indicate the possible state equivalencies. So in this way there are 6 number of states from S0, S1, S2, S3, S4 and S5 along the vertical columns. The, all the states except first one is not to be taken, that is S0 is not taken here. It is started with S1 up to S5, and along the horizontal line we take all the states except the last one. Since S5 is last one, it is not taken here, and each square shows the possible state equivalencies. Here this square represents the S0 and S1. This square represent S0, S2, this is S0, S3, S0, S4, S0, S5, and similarly for rest of the state spaces. So in this way, the unfilled implication chart or the empty implication chart for any given state machine can be drawn. So this is implication chart, unfilled implication chart. Now we shall study the implication chart method with taking some example and find the equivalent states. Here, this example that we have already solved using the equivalence class method in our earlier video, we have taken the equivalence class method and the same example is taken in that video. So here five states are there. The state table contains S0 to S5 states. See the example. Consider the sequential machine given in table 1 using the implication chart method. Find the equivalent states and draw the reduced state table. Okay, so the sequential machine is described in this table containing the 6 number of states starting from S0 to S5, and next state and output values are given here. For input x is equals to 0 and x is equals to 1, having output shared. So uh, see, let us see the implication chart of that machine. The top square is identified by vertical and horizontal intersection of states S0 and S1. It represents the possibility of states S0 and S1 being equivalent. Here, this is the top square, represents the state spaces S0 and S1, and it represents the possibility of states S0 and S1 may be equivalent. So, what we have to do? We have to first fill the implication chart. So, how the implication chart is to be filled? Those steps are given here. First of all, we have to look at the output of the states. So the first is place an X, that is cross, in the squares where the outputs are different. These states cannot be equivalent. So very first thing is to take care of outputs given in the state table, and from that we have to place um, X mark or the cross mark in the state spaces where the outputs are not same. So it means these state spaces where X is placed cannot be equivalent. Then once it is done, what is to be done next? Consider the remaining squares. Look at the state equivalent pairs because output were taken care in first step. Those state spaces having the different output, we have placed the X mark, we have to place cross mark in those state spaces. So the very first step, we take care of output. Then secondly, we have to enter the remaining state spaces. Here, if we see the state table carefully, first state S0 and S1 is to be taken care. So in S0 and S1, see the output here, output Z or X equals to 0, 0, 0, and here is 1, 0. So these two states cannot be equivalent because here output is same, but here under input X is equals to 1, output is different. So we'll have to place cross mark in the state spaces or the squares S0 representing S0 S1 state. Similarly, the rest of the states are to be checked for the output condition and accordingly press the cross mark those squares. In the remaining places like S0 and S2, if we see the output here 0 0 and here is 1 1, means under two input conditions the outputs are same, here 0 0 and here 1 1, means these two states S0 and S2 may be equivalent, and uh, those states which are implied state, we say here S4 S4, both are the next states are same, and according to the properties of equivalent state, each state is equivalent to itself. So this S4 S4 is equivalent, and another pair is here S1 and S3. So we have to place this state pair S1 and S3 in the square S0 and S2. This state pair is called implied equivalent states. Okay, so we'll see here. Okay, first is S0 S2 that is S0 is equivalent to S2 if and only if S1 is equivalent to S3. In the next slide, we'll see how the implication chart is filled. Write state equivalency where S1, S3 in the where S0, S2. Similarly, rest of the values are to be entered or rest of the state squares are to be checked. S0 is equivalent to S4 if and only if S2 is equivalent to S4 and S3 is equivalent to S5. S1 is equivalent to S5 if and only if S2 is equivalent to S3. S2 is equivalent to S4 if and only if S1 is equivalent to S5. And S3 is equivalent to S5 if and only if S1 is equivalent to S5 and S1 is equivalent to S2. Okay, so in this way all the state squares are to be checked and accordingly fill the values of applied state pairs. So we'll see this the example or the state machine where we have to find the equivalent states using the implication chart method. So we'll see the how it is to be entered and how to find the equivalent states. Test equivalencies of each square by testing the applied equivalent state pairs written in each square. If the implied equivalent state pairs are not equivalent for a given square, write x in square. That is what we have discussed already. So this is the unfilled implication chart and we have to fill that implication chart using the values from this state table. In the very first step, we have to check the output of the states and if the outputs are different, we have to place cross mark or the X mark in those state squares. So first we have to check S0 and S1. We'll check one by one. See these two state. The first square is first top square represents the state S0 S1. So we'll check the values of rows S0 and S1. Check the output. Here is 0 0. Output is same and here 1 0. Here output is different. So S0 cannot be equivalent to S1 and under this condition we have to place cross mark in the square S0 S1. So place the cross mark there. Now check the next square, this one S0 S2. So check the rows of the state S0 and S2. First check the output S0 0 0 here 1 1. So outputs are same. For input x equals to 0, the output is 0 and x equals to 1, input x equals to 1, output is 1. So will not place a cross mark in S0 S2 square, so let remain it blank. Next check the S0 S3, see the output 0 0, here is 1 0, so this cross mark is placed in S0 S3. Then check the S0 S4, next square is S0 S4. Here output 0 0 1 1, so these two state may be equivalent, so we'll left it blank. Then S0 S5, last column is last square, here is S0 S5, outputs are 0 0 here and 1 0 here, so we'll place the cross mark since the output is different here. So place the cross mark. Next to check S1 S2, so let us see the S1 S2, check the output, here are same but here 0 1 different, so we'll place the cross mark there. Then next square is S1 S3, check the outputs of S1 and S3 states 0 0 here is also 0 0. So output of S1 and S3 are same, so let remain it blank. Next, S1 S4, S1 S4, check the output. 0 0 same, 0 1 different, so place the cross mark there. Then here S1 S5, check the S1 S5 state. S1 S5, 0 0 0 0, so let it remain blank. S1 S5 square. Then the next square is S2 S3, S2 and S3, check the outputs. 0 0 1 0, since output is different here, place the cross mark in that square. Okay, the next is S2 S4. See the states of S2 and S4. Check the output. Here is 0 0, it is same, and here 1 1, it is same, so let it remain blank. And the next is S2 S5, S2 S5 outputs here 0 0 means it is same, 1 0 different, so we'll have to place cross mark in S2 S5. Okay. Then the S3 S4, check these two states. S3 S4 outputs here is 0 0, is 0 1. Since this output is different, I'll place cross mark in S3 S4 square. Then S3 S5, this one S3 S5, check the outputs. 0 0 0 0 is the output are same, so let it remain blank. And the last square is S4 S5, check the output. 0 0 1 0, here output different, so we shall place cross mark S4 S5 square. So in the first step of filling the implication chart, we have to take care of output state. We have to check the output state, and in we have to place the cross mark, the square where outputs are different. Now the next step is to enter the implied state pairs in the blank square. So let us check the first one, S0 and S2. S0 and S2. We know that their outputs are same, so we have left it blank. Let us see the implied state pairs by which this state may be equivalent. So S0 S2, under x is equals to 0, the next state is S4 and S4. So each state is equivalent to itself, so 4 is not to be written in that square. Here the under input x is equals to 1, see the state, next state here is S3 and S1. So we can say the S0 is equivalent to S2 if and only if S1 is equivalent to S3 or S3 is equivalent to S1. So we'll have to place this implied state pair S1 S3 in the square S1 S0 S2. So let's do it S1 S3. Okay, this state S1 and S3 called implied state pair by which the state S0 and S2 may be equivalent. The next blank square is S0 and S4. So check the S0 and S4 state. Under input x is equals to 0. The next state for S0 is S4 and S4 is S2. So S0, we can say S0 is equivalent to S4 if and only if S2 is equivalent to S4. So just enter that state pair there. It is here. Again, the under input x is equals to 1. Let us check the next state for S0 and S4. It is S3 and S5. So this is the another implied state pair. So enter it here again, S3 and S5. So these two implied state pair are we entered in S0 and S4 square. You can say S0 is equivalent to S4 if and only if S2 is equivalent to S4 and S3 is equivalent to S5. The next square is S1 and S3. So let us check S1, S3. Next state under X is equals to 0. It is S5, S5. Same state. There is no need to write. And under input X is equals to 1. The next state is S1 and S3. Means S1 is equivalent to S3 if and only if S1 is equivalent to S3. So we have to enter that where S1 is equivalent to S3, and according to the property, equivalent state property, each state is equivalent to itself. So each state pair is equivalent to itself. So S1 is equivalent to S3. That is clear. Okay, the next pair is S1 S5. So let us check S1 S5. The next state under X equals to 0, S5 and S1. So enter S1 and S5 here, and under input X is equals to 1, it is S2 and S3. S3 is here, S2 is here. So let us enter the another state pair, implied state pair S2, S3. Okay. So S1 is equivalent to S5 if and only if S1 is equivalent to S5 and S3 is equivalent to S2 is equivalent to S3. Okay. The next square is S2 S4. So let us check S2 S4. Here are the next states S4 and S2, and here S1 and S5. So S2 is equivalent to S4 if and only if S2 is equivalent to S4 and S1 is equivalent to S5. And the last pair S3 S5, check the implied state pair. Here it is S5 and S1, and our input X is equals to 1, S2. So S3 is equivalent to S5 if and only if S1 is equivalent to S5 and S1 is equivalent to S2. So in this way, the implied state values are to be entered in the square where outputs are same. Once it is done, what we have to check? We have to check state equivalency of these state pairs or state squares. So let us check. Now see here is described this slide. Implied state square S0 is equivalent to S2. State square S0 S2 requires that the same thing is described here. The state pair S1 is equivalent to S3 be equivalent. When we look at the implied state square S1 S3, we find that S1 S3 is needed. That is we discussed because state pair S1 is S1 S3 dependent on itself for equivalency. It is equivalent and is according to the reflexivity property here. Therefore, state pairs S0 is equivalent to S0, S2 is equivalent. Let's check the previous slide. S0 is equivalent to S2 here if and only if S1 is equivalent to S3, and if we check this state square S1 S3 1 S3 here, it depends on state pair itself S1 S3. So it is equivalent to itself. So we can say here S1 is equivalent to S3. And since S1 is equivalent to S3, and in this square S1 S3 state are present, so we can say the S0 is equivalent to S2. So here we find that S0 is equivalent to S2 and S1 is equivalent to S3. While in the remaining state squares, we have to check implied equivalency of these remaining states. Here S2 S4 is there, S2 S4, and if we check the S2 S4 state in itself, S2 S4 square, there is S2 S4, here S2 S4, it depends on S2 S4 and S1 S5. So let us check S1 S5, it depends on S2 S3. So let us check S2 S3. Here S2 S3 is crossed, so we have to place cross mark in all the state square which contains S2 S3. So here it will be crossed, this square get crossed, S2 S3. So S1 S5 will get crossed, and where S1 S5 is present, this one square get crossed, this one will also get crossed. Okay, this one contains S1 S5, this will also get crossed, and since S3 S5 square, this one will get crossed, this will also get crossed. So all the remaining 8 squares excluding S0 S2 and S1 S3 will get crossed. So the uncrossed state pairs shows equivalent states. The same thing is described here. Let us go through it. Implied square S0 S4 requires state pair S2 S4 and S3 S5 be equivalent. By investigating that state pairs, we find that S2 S4 depends on S1 S5 and that S3 S5 depends on S1 S5, S1 S2. Further investigation shows that S1 S2 is not equivalent. We place cross in S3 S5 and S0 S4 square. Applied square S1 S5 is dependent on state pair S2 S3. Because S2 S3 is not equivalent, we place cross in the square S1 S5 and square S2 S4. The remaining state pair possible equivalence is S0 S2 and S1 S3 not crossed off. Since they are not crossed off, they are equivalent. The for finding the equivalent state, we have to modify the given state table given in the example. So we found that state S0 is equivalent to S2 and S1 is equivalent to S3. So instead of using these two states, we'll replace it by a single state. So in this state table, S2 is replaced by S0. Wherever S2 is present has to be replaced by S0. Here S2 is present, so it is S0, S0, S0. And where the state S3 is present, we shall write S1 instead of S3. So here S1 is written, S1 is written, S1 is written. And once it is done, prepare the simplified state table. So if we observe this state table, S0, S0, 4 S4 0 0 S1 S1 1 1. So instead of writing these two rows they are same, we will replace it with a single row. So this is single row written in the simplified state table. Similarly, it is to be done for S1 and S3. See here S1 S1 S5 S5 0 0 S1 0 0. So single row is written for S3 and S1 and remaining are taken as it is S4 and S5. So in this way we can find the equivalent states using implication chart method. This method is a very simple as compared to the equivalence class method where we partition the state. The very quick time we can find the equivalent states. Once the equivalent states are found, prepare the simplified state table, and from that we can draw the state diagram, and we can find the Boolean functions for them, draw the circuit diagram from that. Some questions are given on the implication chart. A student have to prepare these questions. What is important implication chart? Explain the implication chart method of state reduction. How implication chart is constructed for one state machine. What are the implied equivalent states? The suitable example. Find the equivalent states of the sequential state machine. Implication chart. Also draw the simplified state table for them. So students are advised to prepare these questions so you can understand the implication chart with good understanding. So with this we conclude the implication chart. Thank you very much.